All right, in this problem, you got a category for hurricane coming along, and it has winds that are up around 60 meters per second. And you got a small beach house. I give you the area of a typical beach house, 130 square meters. That's the area of the roof. Take the density of the air to be 1.29 kilograms per cubic meter, and the pressure is lower here because in a hurricane, the pressure is lower than normal. You'd expect 101,000 pascals in normal pressure, but we're down a bit here. And I give the mass of the roofing material in kilograms per square meter. So you take this number times that number to get the total mass of the roof and multiply by gravity to get its weight. But the question is, what is the net upward force on the roof? Okay. The net upward force on the roof is, we're going to use Bernoulli to get at this. Right? So if we look at the Bernoulli equation, we're going to ignore height because from the bottom of the roof to the top of the roof, the height difference doesn't really make any difference. And so P below the roof minus P above the roof is going to be 1/2 rho V above the roof squared minus 1/2 rho V below the roof squared. That's going to be the pressure difference. And it's straight out of the slides. That's going to be the pressure difference. So we need to take the velocity of the air above the roof divided by the velocity of the air below the roof, right? This, not divide by, velocity of the air above the roof, we're going to square that, calculate this term. Velocity of the air below the roof, we're going to take that, square that term, and that's going to give us our pressure difference. Well, what are all these numbers, right? What is VB? Well, you know, VB is actually 0, right? The air inside the house is not moving, it's the air outside the house that's moving. VA is 58.9 meters per second. So we've got VA, we've got VB, we've got rho. Rho is 1.29 kilograms per cubic meter. And so we've got everything we need to calculate the pressure difference. Okay, so here's the question then. How do you get at the net force? Well, there are two things involved in the force. One, there's the force due to the hurricane. I'll just call that FH, which is just going to be PB minus PA times the area of the roof, right? Pressure is force over area. Force is pressure times area. So you can get the force upward on the roof due to the hurricane with this calculation, all right? And we're ignoring nails and bolts and things like that hold the roof down. But once you get the answer, you'll kind of get the size of the problem you have in keeping a roof on in a hurricane and why you actually have to strap them down pretty tightly with straps that go all the way over the roof and attach to the foundation. Okay, so now we've got the force, the upward force of the hurricane. And what are we looking for next? The force of gravity, which is going to be the mass of the roof times G. Okay, what's the mass of the roof? Well, the mass of the roof is the area of the roof times the mass per unit area. So here in this one, it's 130 meters squared times 29.8 kilograms per meter squared. That gives you the mass of the roof, and then times 9.8 meters per second squared, and you get to the force of gravity downward. And so what we're after is the net force upward, and that's going to be force of the hurricane minus the force of gravity. And once you calculate this, you'll find out that if you don't have anything holding your roof on, it is certainly going to disappear. All right, and there you go. That's it for problem 8.